Today we are starting a new and a very important topic in chemistry called transitions metal. By the end of this lesson, you will be able to first explain what transitions metals are and identify the positions in the periodic table, so you understand where they are found and how they are classified. Second, describe the general properties and special characteristics of transition metals, including what makes them different from other metals. Third, we will observe separation of transition metals ion and explain the color change and other observations that occur during these reactions. Finally, you will be able to relate transitions metals to real-life applications, helping you understand why these metals are so important in industry, technology, and everyday life. Let's begin by finding out exactly what transitions metals are and where they are located in the periodic table.
Transition metals are a group of elements found in the middle section of the periodic table, specifically within groups 3 to 12. These elements are characterized by their partially d orbitals, which contribute to their unique properties and wide range of application. Moreover, they are found in periods 4, 5, 6, and 7, covering elements 21 to 30, 39 to 48, 71 to 80, and 103 to 112. The transition metals have properties that are not in explode metals. For instance, due to the strong influence of partially d field orbital, the transition metals can form colored compounds, complex ions, and have variable oxidation states.
Now we go to the physical properties of transition metal. First, good conductors of heat and electricity. Transition metals are excellent conductors of both heat and electricity. This is due to their large number of free electrons, which can carry thermal and electrical energy efficiently. These free electrons allow the metal atoms to transfer energy quickly. Second, high melting and boiling points. Transition metals also have a high melting and boiling point compared to other metals. This is because, in addition to their outermost electrons, transition metals have a delocalized 3d electrons. These extra electrons increase the strength of the metallic bonds, making the overall structure more stable and harder to break apart. Lastly is higher densities. Another important property is that transition metals tend to have higher densities. This can be explained by the same principle that for their higher melting points. The delocalized electron not only make the metallic bonds stronger but also bring the metal atoms closer together, increasing the density of the metals.
Next, for the chemical properties of transition metal, first we have catalytic properties. Transition metal are excellent catalysts, meaning they speed up the chemical reaction without being used up. Second, we have homogeneous catalysts. Homogeneous catalysts are in the same phase as the reactant, usually in solution. Third, we have heterogeneous catalysts. Heterogeneous catalysts are in different phases, such as solid catalysts in a gaseous reactant.
Now I will explain three special characteristics of transition metals that make them unique in chemistry. Firstly, transition metals have a variable oxidation state. This happens because they can lose electrons from both the 4s and 3d orbitals. This allows them to form multiple oxidation states, making them very versatile in chemical reaction. Secondly, transition metals are great catalysts. A catalyst speeds up reaction without being consumed, and transition metals do this by providing an alternative reaction pathway that lowers the activation energy. Lastly, transition metals form colored compound. This is due to the unique ability of their electrons in the d orbitals to absorb specific wavelengths of light, creating the wide array of colors seen in many metal compounds.
For simple reaction, we take example copper to sulfide react with sodium hydroxide. So when sodium hydroxide is added to copper to sulfide, a blue precipitate is formed, which the blue precipitate is copper 2 hydroxide. The blue color shows presence of copper-2 ions. From the observation, we can see the solution change from the blue color to cloudy blue and the blue precipitate was formed. So why this is happened? First, the blue precipitate forms because of copper-2 ions react with hydroxide ion to produce insoluble copper-2 hydroxide. Second, the blue color occurs because copper-2 ions are transition metal ion with partially filled d orbital which absorb specific wavelength of light.
Now, I would like to explain some real-life application of transition metal in our daily life. Firstly, transition metal are widely used as catalysts in the industry. For example, iron are widely used as catalysts in harbor process. It is important in industrial process to produce ammonia that are mainly used in manufacture of fertilizers. Next, transition metal are also important in pigment and color. A copper compound are usually used to produce green or blue color in some product. This color can be found in paints, ceramic, and also glass to give them an attractive and vibrant appearance. Lastly, transition metal play major roles in construction and alloys. A good example is stainless steel, which is an alloys that are made of iron, nickel, and chromium. Stainless steel is strong, resistant to corrosion, and also safe for daily use. Therefore, it's commonly used in cookware such as pots, pans, and kitchen utensils.
In conclusion, transition metals are very important in chemistry and in our daily life. They have special properties such as forming colorful compounds, having different oxidation state, and acting as good catalysts. Because of these properties, transition metals are used in many industries. They also have strong physical properties like high melting point, good electrical conductivity, and high density, which make them useful for building machines and electrical wire. Metals like iron and copper are especially important. Iron is used in making ammonia and building, while copper is commonly used for electrical wiring and pigment. Overall, understanding transition metals help us see how chemistry is used in technologies and construction and everyday life.